Rule extraction from trees. A decision tree does its own feature extraction. The univariate tree only uses the necessary variables, and after the tree is built, certain features may not be used at all. We can also say that features closer to the root are more important globally. For example, the decision tree given in figure 9.6 uses x1, x2, and x4, but not x3. It is possible to use a decision tree for feature extraction. We build a tree and then take only those features used by the tree as inputs to another learning method. Another main advantage of decision trees is interpretability. The decision nodes carry conditions that are simple to understand. Each path from the root to a leaf corresponds to one conjunction of tests, as all those conditions should be satisfied to reach to the leaf. These paths together can be written down as a set of if-then rules called a rule base. One such method is C4.5 rules. This is proposed by Quinlan in 1993. For example, the decision tree of figure 9.6 can be written down as the following set of rules. R1 is if age is greater than 38.5 and years in job is greater than 2.5, then y equals to 0.8. Rule 2 is if age is greater than 38.5 and years in job is less than equals to 2.5, then y is equals to 0.6. Rule 3 is if age is less than equals to 38.5 and the job type is equals to 8, then y is equals to 0.4. Rule 4 is that if age is less than equals to 38.5 and job type is equals to 8, then y equals to 0.3. And rule 5 is that if age is less than equals to 38.5 and job type is equal to C, then y is equals to 0.2. Such a rule base allows knowledge extraction. It can be easily understood and allows experts to verify the model learned from the data. For each rule, one can also calculate the percentage of training data covered by the rule, namely rule support. The rules reflect the main characteristics of the dataset. They show the important features and split positions. For instance, in this hypothetical example, we see that in terms of our purpose y, people who are 38 years old or less are different from people who are 39 or more years old, and among this later group, it is the job type that makes them different, whereas in the former group, it is the number of years in a job that is the best discriminating characteristic. In the case of a classification tree, there may be more than one leaf labeled with the same class. In such a case, these multiple conjunctive expressions corresponding to different paths can be combined as a disjunction, or the class region then corresponds to a union of these multiple patches, each patch corresponding to the region defined by one leaf. For example, class C1 of figure 9.1 is written as if x is less than or equals to W10, or x1 is greater than W10, and x2 is less than or equals to W20, then C1. Pruning rules is possible for simplification. Pruning a subtree corresponds to pruning terms from a number of rules at the same time. It may be possible to prune a term from one rule without touching other rules. For example, in the previous rule set for R3, if we see that all whose job type is equals to A have outcomes closer to 0.4, regardless of age, R3 can be pruned as R3 prime equals to, if job type equals to 8, then y equals to 0.4. Note that after the rules are pruned, it may not be possible to write them back as a tree anymore.